Alright, welcome to Unit 4. This unit is on exponents and logs. So today in this video we're going to look at several exponent rules, none of which should be brand new to you. So the first situation, if we are multiplying and we have the same base, call that base x, recall that you are going to add your powers. So some examples, x to the 7th times x squared. It's not going to be x to the 14th, it's going to be x to the 9th. Something like 3 to the 8th times 3 to the negative 5 power. Now the base is not going to become 9, it's going to remain a 3. Add your powers and you'll get 3 right there. Okay? Something like negative 2 to the 4th times negative 2 to the 6th. That's going to give us negative 2 to the 10th. Again, keep the base the same and add your powers. Okay? Moving on to the next rule. When we divide and we have the same base, you're going to subtract your powers. Top one minus bottom one. So, x to the 10th over x to the 5th. A lot of times people think that's going to become x squared. It's actually x to the 5th power. Again, you're subtracting your powers. Something like 9 to the 4th all over 9 to the how about 3rd power. That's going to give you 9 to the 1st. Okay? So when you are dividing and you have the same base, you want to make sure that you are subtracting. Let's do one more quick one. How about 5 to the negative 3 all over 5 to the 8th? Well, this would be 5 to the negative 3 minus 8, which is 5 to the negative 11. Okay? Next, let me bring this up. Now we have a power to a power. When you have a power to a power, this is where you're allowed to just multiply those powers together. So x to the a times b. So if we have x cubed to the 5th power, it's not going to be x to the 8th. You would only add the powers if you have the same base and you're multiplying. Here, power to a power, just go ahead and multiply x to the 15th. Something like 2 to the 4th to the power of 3, well, that's going to give you 2 to the 12th. Okay, something like negative 3. Let's do negative 3 to the 5th power. All right, and suppose it has a negative 2 on the outside. Okay, it doesn't matter if it's negative, you still have a power to a power. So you're going to have negative 3 to the negative 10. Okay, so power to a power, you're just going to multiply and you keep that base the same. All right, moving on. So here we have x times y raised to the a. Well, think of it as you can distribute your power of a. And when we studied the binomial theorem in the first unit, recall that we saw some situations where maybe you had 2x cubed. All right, so you cubed both parts, and in this case we'd get 8x cubed. Okay, maybe you have something like negative 3 y z, that whole quantity squared. Well, again, you would distribute that power all the way through. So in this case, you'd have 9y squared z squared. All right. Next, we also saw this when we did the binomial theorem. If you have a fraction raised to a power, you would just distribute that power to each part, both the numerator and the denominator. So talking about things like maybe 3 over x raised to the 4th. Well, this would be 3 to the 4th over x to the 4th, which is 81 over x to the 4th. Maybe you have 2 over 5 to the 3rd power. Well, this is 2 cubed over 5 cubed, so that's 8 over 125. So you're going to simply distribute your power to each part. Okay, next page. So our first rule here, anything to the 0 power is 1. So 5 to the 0 power is 1. Negative 2 to the 0 power is 1. Be careful if you see something like this. This is not 1. If you write it like that, only the 3 is raised to the power of 0. So this is actually negative 1. Okay? So if we wanted to say the entire quantity negative 3 to the 0, we'd have to write it like we did the negative 2 up above. Okay? So be careful. Something like 5xy to the 0. Well, this is just going to be 5x, all right, times 1. So the whole thing isn't to the 0 power. But if you see 5xy, the whole quantity to the 0, well, now it's 1. Okay? Next, we have some negative exponents. X to the negative a. So x raised up to the negative a power can be rewritten as 1 over x to the positive a. So we're talking about things like x to the negative 6. Well, that's the same as 1 over x to the positive 6. Or if I say to you, without a calculator, tell me what 3 raised to the negative 2 is. Well, you have to know that's the same as 1 over 3 to the positive 2, or 1 over 9. If I say to you, tell me what 5 to the negative 1 power is, without a calculator, it's not negative 5, it's 1 over 5 to the positive 1, or just 1 over 5. Okay. One more. 4 to the negative 3. Okay. It's not negative 12. It's 1 over 4 cubed. All right, which is 1 over 64. Okay, so you get the idea. Next, working backwards here. If we have 1 over x to the negative a, this x to the negative a in the denominator can be brought up. I'm going to keep that 1 there up top. I can bring this up as x to the positive a. Alright, so you just have x to the a. So if you have 1 over x to the negative 3, that's the same as x cubed times 1, but it's just x cubed. You might see something like 2 over x to the negative 5. Well, this is the same as 2x to the positive 5. Okay? Or maybe we have 4 over 2 to the negative 3. This is the same as 4 times 2 to the positive 3. Okay, so 4 times 8, or 32 in that case. Next, we have some fractional powers. 9 and 10 kind of go together here. X to the 1 over n power. Well, this is going to correspond to a radical. The base of x is going to be in the inside. The n, which is the denominator, that's going to be the root number. And the numerator of 1, that's going to be the power on the inside. So if I give you x to the 1/2, that is the same as the square root of x. Technically there's a little 2 on the outside, and there's really a 1 right there, but if it's a square root, we don't tend to put the 2 on the outside. It's assumed to be there. Okay? So something like x to the 1/3, well, that's the cube root of x. If I ask you without a calculator to tell me what is 25 to the 1/2 power, you have to know that that's just the square root of 25, which is 5. Or if I say, tell me what 8 to the 1/3 power is without a calculator, you need to know that this is the cube root of 8. Technically 8 to the 1st, but just 8. That's going to give us 2, because 2 times 2 times 2 will give us 8. If I say, tell me what, let's go with, how about 64 to the 1/2 power. Okay, again, that's just the square root of 64. Alright, so 8. Alright, so when you have a 1, alright, in your numerator, the power is just going to be a 1 on the inside here. It gets a little bit more complicated when you see x raised to the a over n. Same idea, still going to have an x there, still going to have n, okay, for your root, and now a is what we see on the inside. So if we have, how about x to the 2/3, that's the same as the cube root of x squared. Okay, let's do some examples here. So what if I were to give you, how about 25 raised to the 3/2 power? Well, this is the same as the square root. Okay, you don't have to put that 2 there on the outside if you don't want to. Okay, it's the square root of 25 cubed. Now you have a choice here. You could actually do 25 cubed first and then attempt to square root it. However, if you don't have a calculator, if you're not allowed to use a calculator, you're going to want to do the square root of 25 first, get 5, and then raise it to the power of 3 to get 125. Okay. How about 32 to the 2/5? Okay. So this would be the 5th root of 32 squared. So again, you don't want to do 32 squared without a calculator and then somehow try to figure out the 5th root. Instead, you can go this direction. The 5th root of 32. Well, if we're having to do this without a calculator, it's going to be a nice clean integer. The 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 will give you 32. So you're left with 2, and then this power comes along for the ride, leaving us with 4. Okay, for our answer. Let's do one more, and let's throw in a negative. What if we have something such as, let's go with 16 to the -5/2. Well, right away you want to kill that negative. So you want to replace it with 1/16 to the +5/2. Well, this is the same as 1/. Well, I see a 2 in my denominator, so that means I'm going to have a square root. So I don't really have to put the 2 there, but I will just to show you. All right, and then we have 16 to the 5th power. Well, from there, we're going to have 1/. Take your square root of 16, that's going to give you 4 to the 5th. So 1/4 to the 5th would be, actually it's not 4. Yeah, it is 4 to the 5th, so 1/4 to the 5th, all right, would be your final answer, whatever that's equal to. Okay? So that's it for now. Goodbye.